of projectile motion in this problem. Let's now look at another problem. A plastic ball that is projected with a velocity of 15 meters per second stays in the air for 2 seconds. At what angle with respect to the horizontal was it projected? In other words, what are the given things? We are told that the projectile was projected with a velocity of 15 meters per second. That is V0. And it stays in air for 2 seconds. That is the time of flight. We know the initial velocity. We know the velocity of projection V0. We know the time of flight. We need to find the angle of projection. Alright, let's set it up. Here we have a plastic ball projected with a velocity of 15 meters per second at an angle theta, and we need to find that angle theta. Now, the velocity has a horizontal component 15 meters per second cos theta and a vertical component 15 meters per second sine theta. Alright, V0 is 15 meters per second. The x component of that velocity is 15 cos theta, and Vy0 equal to 15 sine theta. I hope you distinguish between the x and y component. The x component does not change, so we don't need to write Vx0. Vx remains a constant right through the flight. So Vx is 15 cos theta, but this is the initial vertical velocity. So we need to indicate it as Vy0. And the time of flight is 2 seconds. If the time of flight is 2 seconds, what is the time taken to reach the maximum height? The time taken to reach the maximum height is 1 second. Alright? Now, at the maximum height, Vy equal to 0. We just used that in our previous problem. And what is the equation for Vy? Vy equal to Vy0 minus gt. There you are. And Vy0 is 15 sine theta. And this t equal to 1. 1 second is the time taken to reach the maximum height. So we have V0 sine theta minus gt equal to 0 at the maximum height. The vertical velocity is 0 at the maximum height. And therefore, I'm going to solve for sine theta from here. Sine theta equal to gt divided by V0. That's okay? Let's leave that equation there. And, well, we know the value of gt over V0. You see, gt over V0, g is 9.8, t is 1 second, V0 is 15 meters per second. Therefore, sine theta equal to 9.8 over 1.5. Therefore, theta equal to sine inverse of 9.8 over 15, not 1.5. Sine inverse of 9.8 over 15, and that is 40.8 degrees. So the angle of projection is 40.8 degrees. That's the first part of the problem. Let's see what the second part is. What is the maximum height reached by the ball? Well, what is the time taken to reach the maximum height? If the time of flight is 2 seconds, the time taken to reach the maximum height is 1 second. Therefore, the maximum height is the y position at that time. What is the equation for the y position? The y position is y equal to Vy0t minus 1/2 gt squared. Alright? The maximum height is the y position of the ball when t equal to 1 second. And the y position is Vy0t minus 1/2 gt squared. What is Vy0? Initial vertical velocity is V0 sine theta. And we know that V0 is 15, sine theta is 40.8 degrees. So Vy0 is 15 sine 40.8 degrees minus multiplied by the time is 1 second minus 1/2 gt squared. T is 1 second. And that will be 4.9 meter. Alright, let's look at another problem. An arrow was shot at an angle of 55 degrees with respect to the horizontal. The arrow landed at a horizontal distance of 875 meter. Find the velocity of the arrow at the top of its path. Well, the arrow was shot and it rises, reaches the peak and then goes down. We need to find the velocity at the top. Well, the velocity at the top has only one component. What is that component? The horizontal velocity, because at the top of the path the vertical velocity will be 0. The only velocity at the top of the path will be the horizontal component of the velocity. Well, we don't know the velocity of projection, so it is not very easy. So let's find that first. Well, here is the arrow projected. The arrow goes like this. We need to find the velocity at the maximum height. The angle of projection is 55 degrees. The horizontal range is 875 meter. Well, what is the equation for the horizontal range? The horizontal range is the horizontal velocity multiplied by the time of flight. And the horizontal velocity is V0 cos theta. So, x equal to 875 meter. First, we find V0, the velocity of projection. Without that, we cannot answer this question. So we need to find V0, the velocity of projection. And what is the horizontal range? What is the equation for the horizontal range? This is the equation we developed for the horizontal range. In other words, when you multiply the horizontal velocity with the time of flight and simplify it, this is the equation we arrived at. This is the equation for the horizontal range. X equal to V0 squared sine 2 theta over G. Well, we know theta, we know G, we know X. You see? And so, it's easy now. So, V0 squared equal to, solve for V0 squared. V0 squared equal to x times G divided by sine of 2 theta. There you are. Now, X is known, G is known, theta is known. We use all those values and calculate V0 equal to square root of that quantity. And now, X equal to 875 meter, G is 9.8 meter per second squared. And theta is 55 degrees, 2 theta is 110 degrees. And that gives you the velocity of projection is 95.5 meter per second. And you must be able to now do this problem on your own. If this is the horizontal, if this is the velocity of projection V0, what is the velocity at the maximum height? at the maximum height, the velocity is simply the horizontal component, which is V0 cos theta. V0 you know, theta we know, therefore you can find that component of the velocity. Alright. At the maximum height, Vy equal to 0. And its velocity is simply made up of Vx. Vx equal to V0 cos 55 degrees. At the top of the path, Vy equal to 0 and Vx equal to V0 cos 55. Therefore, the velocity at the top is V0 cos 55, and that will be 95.5, and is the value of V0, times cos of 55 degrees, and that is 54.8 meter per second I. It is directed in the x direction. Okay, another problem. Find the angle of elevation theta of a gun that fires a shell with a muzzle velocity of 125 meter per second and hits a target on the same level but 1.55 kilometer distance. Well, what are these given data we have? We need to find the angle of projection theta. We know the velocity of projection V0. V0 is 125 meter per second. What else do we know? We know the horizontal range, the horizontal distance traveled. Alright, the tank fires a shell with a velocity of 125 meter per second, and the horizontal range is, there you are, the horizontal range is 1550 meter. The velocity of projection is 125 meter per second, and the shell comes over here at a distance x equal to 1550 meter. Alright, how do we use these data to find the angle of projection? Well, you know the horizontal range x equal to V0 squared sine 2 theta over g. We used that in the previous problem. Okay, therefore sine of 2 theta equal to xg divided by V0 squared. Now that will be g we know, x we know, and V0 we know. All these values you know. Therefore, sine of 2 theta equal to 0.9721. If sine of 2 theta is 0.9721, what is the value of 2 theta? 2 theta is sine inverse of 0.9721, and that will be 76.4 degrees. If 2 theta equal to 76.4 degrees, what is the value of theta? Theta is 38.2 degrees. Okay, that's now.